I'll be showing you the simplification method for subtracting polynomials. So, first thing whenever we see brackets in math is we check inside of them to see if there's anything that needs to be combined. In this case, we see we have an a squared, an a, and a constant of -2. None of those have the same base, so that I know none of those can be combined. I look at my second bracket and I find the same thing, an a squared, a -3a, and a constant of 7. I know none of those can be combined, so I'm good to go to distribute and get rid of my brackets. In front of this first bracket, I don't see any numbers or symbols, so I know that there's my invisible +1, which means I can distribute that throughout the brackets. And as we learned in the adding to method video, if you watch that, whenever you distribute a +1, nothing changes, meaning +1 times 3a still equals 3a squared, and so on. So we can just rewrite that first polynomial knowing nothing changed. However, when we see a negative in front of a bracket, we have to be really careful. And I like to write out the rhyme that when you see a negative and you're going to distribute that through the bracket, you're going to flip the sign every time. So in this case, I see I have a positive, a negative, and another positive. So I know this one's going to become negative, this one's going to become positive, and this one's going to become negative. I'm going to flip the sign every time. So I write down my -a squared because I distributed this negative into it, or you could even say a -1 because we know there's that invisible 1 there. So -1 times a squared is -a squared. -1 times -3a squared becomes +3a, and -1 times +7 becomes -7. So there you go, I've gotten rid of my brackets. Now I'm ready to move forward with combining like terms. And I like to do this by marking it up and symboling it, as I find that makes it easier for your brain to see what you're going to be combining. So I start with my first term, and I'll give that an underline. I see I have an a squared. Now I'm going to look down the line and see if I have any other a squares. I have an a -2. Oh, there's an a squared, so I'm going to underline that. 3a and a -7. So, no, I'm all done with my a squareds. So I go back to the beginning. Now I have a 2a. Let's give those a squiggly. I look down the line again, and I see I have another a variable with the +3a. And that leaves me with my two constants, -2 and -7. Now, I suggest rewriting out this polynomial in order of terms that you're going to be combining to make it easier for your brain to see how you're going to be putting this together. Meaning, I'm going to rewrite 3a squared, but I'm going to put this -a squared right next to it because I know those are eventually going to be combined. Then I'll put my 2a, and I can cross these out, by the way, as I go, make it easier for my brain to see what I've done. Now I'm going to add my 2a, and I know that this, because of my squiggles, I can see easily that that's my 3a that's going with it, so those are done. And then my two circles are left, meaning I have -2 minus 7. Now it's easier for my brain to see that those two are going together, those two, and what symbols are attached to each, because remember, when you're rearranging terms, you have to keep whatever symbol is attached to that number, meaning right here with this 3a squared, there's this positive that's invisible there, so I know to keep this term down here positive. Same thing with my 2a, there's a plus, so I made sure there was a plus down below, and with my -2, made sure it was a -2 down here as well, and so on and so forth. All right, so then what is 3a squared minus a squared? We know that that is 2a squared because whenever you have a variable, there's, again, the invisible 1 that we don't see, so you're essentially saying 3 minus 1. So I get my 2a squared, and then I have 2a plus 3a, which we know to be 5a. And again, whenever you are adding or subtracting polynomials, you have to ensure that your base stays the same. So that's why I still have my a squared, because a squared minus a squared is still going to be a squared. And 2a plus 3a is still going to be a. So I leave that alone. Then I have my constants at the end, -2 minus 7, which we know to be -9. And there we go. We're done combining terms, and there's only one step left, and that's to ensure that you have the correct order of polynomials. Reminder that when we're writing out polynomials, we're very concerned with order of degree, starting with the largest to the smallest. So let's double check our degrees. We know that the degree of this term is 2 because that's what the exponent is off this a. And this one is 1 because, again, we always have this invisible 1 exponent on any variable terms. And our 9 doesn't have any variable terms, so we don't care what the degree of that is. And we say, oh yeah, this is in the correct order. 2 is higher than 1, which means this is all in the correct order and we're done. This would be your answer. There you go.